bit about significant figures, and the test is not super heavy on them when you do calculations, but we need to know that you do understand what significant figures are, how to round, and how to perform calculations on them. So let's just take a look at this pretend number that we got here, and notice that we have right now 1, 2, 3, 4, 5. We have 6 significant figures. This 0 is significant because it is between two non-zero numbers. Now let's round it to 5 significant figures. So if we were to round it to 1, 2, 3, 4, 5 significant figures, the number after the 4 is a 3, so we'll just leave that as a 4. So rounding it to 5 significant figures, the number would be 1.7094. Okay, let's round it now to 4 significant figures. 1, 2, 3, 4. The number that is after your 4th digit, which is a 9, the number that is after that 9 is a 4. So we do not have to round it up. We're going to just keep it at 9. 1.709. Okay, now we're going to round it to 3 significant figures. So if we have this number and we count to 1, 2, 3, that 0 is followed by a number that's greater than 5. Okay, it's followed by a 9. So we're going to round that up to a 1. So at 3 significant figures, that number would be 1.71. Now if we were to round this to 2 significant figures, 1, 2, the number that follows the 7 is a 1, so we would say 1.7. If we round this to to 1 significant figure, the number that follows the 1 is a 7, so we would report it as 2. Alright, so let's just do another quick little sample problem here. Let's say you have the number 10.7328. And let's round this to 2 significant figures. Okay, so your first one, your second one, the number that follows the 0 is a 7. So the correct answer rounded to 2 significant figures would be 11. Alright, now let's take this to the next step, which would be performing a calculation involving significant figures. Calculate the density of an object with a mass. Density is mass divided by volume. The mass is 73.2 grams and the volume is 10.008 milliliters. Okay, this is a crazy example because you'd be crazy to use a balance that only gave you reported your number to a 1/10 of a digit, but then calculate this volume with like a pipette or whatever. That'd be kind of a crazy problem, but we'll just go with it. Now, remember, whenever you're dividing or you're multiplying, you have to figure out which gives you your least number of significant figures, because that is like your least precise number. Your answer has to keep that many significant figures. So what I'm going to do is count. I've got 1, 2, 3 significant figures here, and these zeros are between non-zero numbers, so everything's significant here. I've got 1, 2, 3, 4, 5 significant figures here. So I'm going to take my calculator, and when I say $73.2 divided by 10.008 it gives me 7.31414 blah 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 blah. I know it's hard for you to see. 7.3141 blah 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 blah. Okay, now I can keep the lowest number of significant figures. So I can only keep 3 significant figures. That's all I can keep. So I start out here and I count 1, 2, 3. So I can keep my 7.3, and this number here I have to decide, do I need to round it up or do I leave it the way it is? The number behind the 1 is a 4, so I do not round it up. My answer in correct significant figures is going to be 7.31 grams per milliliter.